Here's another type of substitution you might encounter for ODEs, and I call these kind of contrived substitutions because it's as if someone came up with a substitution you need to do and then made a difference equation just for that substitution. So here we go. You can see them though in your coursework, and this kind of emphasizes how difficult it is to make nonlinear difference equations that can be solved. So here we go. Let's jump in. So I've got this difference equation, y prime plus x equals square root of x squared plus y squared. I don't know how to solve that, but we're told to use a substitution, so hopefully, whoever made this problem knows what they're doing. I did, so let's hope so. So what if we try a substitution u equals x squared plus y squared? Right? So if we take the derivative, then we're going to end up with u prime is equal to 2x plus 2y prime. And look at that. So here we have x plus y prime, and here we have 2x plus 2y prime. So if we take a half, so 1/2 u prime equals x plus y prime, that's going to work out really well. And this is why this problem is contrived. So let's go through here. So I can replace the left-hand side of the ODE with 1/2 u prime, and I can replace the right-hand side with the square root of u. All right, well, this is actually a separable difference equation. So du dx equals u to the 1/2. All right, so let's go ahead and separate, and let's go ahead and move the 2 to the other side while we're at it. So this will be u to the negative 1/2 du equals, I'll leave a space for an integral sign, 2 dx. Yeah, and we can integrate. All right. So u to the negative 1/2, if I integrate that, it'll become u to the positive 1/2. All right, but then I have to take care of the power rule, so I need to put a 2 in front. All right, and that'll end up equaling, so 2 integrates to 2x. I've got my plus c. All right, well, let's go ahead and divide by 2. So I get u to the, well, let's square root of u equals, let's see, divide by 2, I just get x plus c over 2. But again, I can absorb that c as a constant into the constant. That's x plus c. Okay, that's not too bad. And then I can just go ahead and square that, I suppose. So then we get u is equal to x plus c squared. All right, and now next step is we need to put back in the substitution we did. So then I have u was x squared plus y squared. So x squared plus y squared is equal to x plus c, the whole thing squared. And then, okay, so then I have y squared equals x plus c squared minus x squared. And then if I want to, I can square root. So I get, y equals plus or minus square root of, let's see, x plus c squared minus x squared. And if for some reason you want to, keep going, we can probably, this will end up making an x squared, so we could actually, it's debatable if it's getting any simpler. This ends up being x squared plus 2xc plus c squared minus x squared. All right, well, that's plus or minus square root of, okay, it's just 2xc plus c squared. So yeah, I don't know if you'd count that any simpler, but we did get rid of the x squared term. But yeah, this was a fairly contrived example, and this ended up being the solution. And it just kind of emphasizes, this example, it's harder to make anything in between quick and easy and impossible. And this one is closer to the quick and easy, but, the nonlinear differential equations are so hard to solve that it's hard to come up with examples for them.